Welcome to Legends of Data and AI. Each episode includes inspiring and actionable data and artificial intelligence insights from global leaders across industries. Your host, Dr. Usama Fayyad, was the first Chief Data Officer at Yahoo and is Chairman of Open Insights and Executive Director of the Institute for Experiential AI at Northeastern University.
Welcome everyone to another episode of Legends of Data and AI. I'm Usama Fayyad, Executive Director at the Institute for Experiential AI at Northeastern and Chairman at Open Insights. With me today is a special guest, an old friend from a long time ago, back when we both were graduate students and kind of looking at the world with our innocent eyes. Oren Etzioni. Oren today is the CEO of the AIlen Institute for Artificial Intelligence, or AI2. He has been and still is a professor at the University of Washington in Seattle, and is also a venture partner at Madrona, which is one of the big VC firms in the Seattle area. Oren has also done several startups in the AI and machine learning space, so kind of sees the world from multiple places. And honestly, Oren, welcome, and it's great to have you on the podcast.
Thank you so much, Usama. I just want to say that it's a particular pleasure because I am a huge fan of your work ever since grad school, where I remember reading your early papers on decision trees and how much they influenced me. You mentioned startups, advocating for an investment in one of your startups back in the day. So I feel like I could equally well be interviewing you, but I don't run a podcast, so I guess we're this way.
Okay, wonderful. So Oren, great achievements with AI2, and congratulations literally on creating one of the top AI research institutes in the world, in my opinion. I know one of the founding principles of the late Paul Allen was to promote and advance AI for good. How do you define good versus not good? In particular, advances in tech can typically be used in many and often unpredictable ways. And people, for example, also refer to dual-use technology in the world of civilian versus military uses. What is the approach you have to stick to this AI for good goal?
So first of all, you're right. Our mission is AI for the common good, and it can be challenging to define. The approach that we've taken is to assume that basic research, the kind that we do and publish in premier conferences, it's too difficult to tell what the exact uses will be. And so we are generally pro basic research that's published and available. What I think is clear is that there are certain applications that raise concerns. Facial recognition is an example. I'm not going to say facial recognition is bad. Obviously, there are good uses of facial recognition but I think there are also bad ones, and we've seen that, for example, in China. So in general, we avoid the use of personally identifying information in our systems. That, for example, is one of the guiding principles. Another one, of course, is about autonomy. So I think most of us, if not all of us, find the idea of an autonomous weapon system, an autonomous offensive weapon system, very scary, right? Because it can decide to take a human life. And those of us who are immersed in AI know, of course, how brittle it is, how easy it is for an AI system to make a mistake. And so we obviously want to avoid that. So I would say that our focus is on avoiding applications that are potentially very disruptive.
It's a great philosophy, especially avoiding the personally identifiable information whenever possible. Some people in AI go after attempting to explain how human intelligence works. Others focus on advancing our computing capabilities to solve problems that we think require intelligence, and thus getting a hint as to how that might work. The problem, of course, is solutions may have nothing to do with how humans or animal intelligence work. They just solve the problem, be it in chess or in recognizing objects or what have you. What are your views on these kind of philosophies?
So I think you laid it out very nicely, and I would go further and just refine that a little bit and say that I think of maybe four main approaches. The first one is neuroscience. You can think of it as analyzing the hardware of intelligent systems, in this case, human hardware, if you will, or wetware. The second one is psychology, particularly cognitive psychology, which is, again, studying intelligent functioning in humans. The third one is the approach that we've taken, which is advancing computers. And the fourth is philosophical, very much kind of armchair theorizing on it. I think each of them has their uses and their benefits. I'm personally particularly fond of ours, and that's because we've been able to make very impressive progress. Actually, all these fields have made progress in their own way, but I being a somewhat impatient person, really enjoy the tangible progress that we have. For example, neuroscience is still trying to figure out very basic things about the brain and so on and so on. And we seem to be continually creating increasingly sophisticated and powerful technology.
Oren, can you share a story or two on how machine learning / data science or AI in general were transformative to an organization or business? What do you consider kind of the most convincing use cases or stories here that show the value of the field?
Sure. So again, this is follows directly from your previous question, right? We are seeing how technology can be powerful. And I would say the most amazing thing about AI from my point of view is how broadly transformative it is. Andrew Ng said AI is the new electricity, right? And of course, that makes it sound like it's plug and play, which is not quite right? We know just how much work it takes. But that said, you can really point to every human area of and see progress there. So to give a few specific examples very quickly, fighting climate change, Google reportedly uses AI in their data centers to cut down on energy use in a substantial way. One of my personal favorite examples is we used in a startup called Faircast, we use data mining AI to anticipate airfare fluctuations. So we could tell people the right time to buy their ticket and save money. That's an example there. You see examples in human resources, in healthcare, in reading radiological images, in medicine. Really, it's kind of like you throw a dart. You throw a dart on any field, and I will give you uses of AI in that field.
Yeah, in fact, very similar answer to one that Jan LeCun gave. In fact, he went a bit in an episode on this podcast. He went a bit more extreme and said, if you take the AI out of the Google search engine or the content understanding or moderation or from Meta, Facebook's algorithms, then those companies wouldn't exist. And they're worth hundreds of billions of dollars. So he can quickly quantify it. Most real applications of AI are very much machine learning dependent. That's kind of a reality of the AI world we live in because there's a lot of data out there. And a lot of machine learning successes seem to be very focused nowadays on using these extremely complex models in deep learning with very complicated architectures of neural networks that are kind of hard to understand. Many people claim, overfit, the latest models in the whole, foundation models, I don't like the name, have, 1 trillion parameters. If that's the approach, if deep learning is the approach, what do you think happens to the rest of AI outside of DL?
So It's my belief, and this is something that Jan LeCun and I might disagree on. Actually, we disagree about his previous statement. I think that Google and Meta had, quite a bit of value before they were using AI. And furthermore, I don't think we should blame them for many of the excesses of these companies, particularly Meta. But that's a conversation for another day, perhaps. So to answer your question directly, I think that deep learning is an extremely powerful technology for data modeling, but I think that there's more to intelligence than that. When we think about decision-making, when we think about representing knowledge, when we think about constraining and improving the behavior of deep learning algorithms, and particularly when we think about asking questions, right? There's a famous line from Pablo Picasso who said, computers are useless, they just answer questions. The implication being that posing the question in the first place is where supreme intelligence comes in. So we can now build deep learning models, right, that are trained on, say, Picasso's paintings and can do a reasonable job of copying a Picasso painting. But that's quite different than deciding what to paint in the first place, deciding what ideas you want to convey. How do you fit into the artistic context that's playing out over centuries? Those are the sorts of things where simple deep learning is not going to do it.
That's what a great quote. I wasn't aware of it, and it's extremely apropos here from Pablo Picasso. Moving on to another question. I often say, we haven't had major or as many advances on algorithms for machine learning and AI, over the last, 7-8 decades. We definitely live in a world where we have a lot more data than we've ever had, and the data sets continue to grow exponentially or super exponentially. In order to keep up, does this mean that the science of AI converges on the science of dealing with data?
Wow, well, that is really a fascinating topic. I think we have seen that increases in data set size have tremendous impact. And this goes all the way back to the famous paper by Banco and Brill, I think out of Microsoft Research, right, where they showed in some context that a simple algorithm with a lot of data will often outperform, particularly in the limit, when the data set gets very large, outperform more complex algorithms. That said, I think that sometimes people can overstate the role of data, because to process that data effectively, we have needed to make changes to the algorithm, better regularization.
Yes.
Thank you. Functions, right, to avoid overfitting, better scaling to support that. And I think maybe the best example of this currently is what's called the transformer models, right? These models started in natural language processing, have proliferated. We're now seeing them in computer vision and in other areas of AI. And the transformer model is a new algorithm, right? It's an algorithm that's particularly adept at using billions of sentences and trillion plus parameters, but it is essential to the progress of deep learning. So I think we're really seeing data, algorithms, and compute moving hand in hand to create this new reality.
That's a great answer. There was a famous project called Psych by Doug Lennart and team, which targeted building common sense reasoning by building a large knowledge base of facts and adding in an ability to reason. Since then, we've had Wolfram Alpha, and I know AI2 has created the Delphi system. How do you characterize advances or weaknesses of these approaches?
These approaches like Psych or the new ones?
Well, both. I mean, Psych went on for a long, long time and still goes on, as I understand it. The new ones are also, trying to solve some problems, sometimes compellingly, sometimes they're challenged. So, in general, what do you think of this area, as a whole?
Well, let me start with psych, because historically it was very early. I think started maybe even in the 70s or 80s, which is very much a long time ago. And I think Doug Lennott asked a very courageous question, right? At the time where nobody was willing to entertain this, he asked, how do we build AI programs with common sense? And he started using the methodology of expert systems at the time, which was handwritten, write down a large number of facts and axioms and so on. As the project, the psych project progressed, he kind of gave up on academic AI. He stopped publishing, he stopped doing bona fide experiments. And there, I think, is where psych went awry. I am a great believer in the review process, in the scientific process. And so the fundamental huge difference between these projects is that all the projects you mentioned, whether they're deep learning based or not, other than psych, are bona fide academic projects where we can skeptically assess them, we can review them, subject them to peer review, et cetera. Now, if you go to the technological issues, it's very interesting because I think one thing that we learned from psych is that it does not seem possible to just sit down and type in all these axioms. We need some sort of model that automatically learns them. And so I think that is a huge difference. And now the question becomes, is learning them enough? In other words, it really goes back to the fundamental questions in cognitive psychology and philosophy. How much innate structure do you need? And again, people like Jan LeCun and others will disagree on this. Some will say you need very little, and others like Gary Marcus will say you need quite a bit. So I think that's a very interesting discussion. And it's taking place right now in a respectable experimental AI way. Psych, unfortunately, has kind of taken a sharp turn outside of the playing field.
Yeah, couldn't agree with you more on the importance of the scientific method and kind of the systematic answering of questions or hypotheses. A very related question to this, search engines have definitely become indispensable in our lives. Yet, with the great rise of statistical search engines, and those are the practical ones working out there, Google et al., the use of semantics and semantic search has been a challenge. Why do you think that is? Will we start seeing more semantic search get real traction at big scale?
So I think that search is an absolutely fascinating case study here. And what we've seen, starting with information retrieval and continuing with increased use of statistics and deep learning in these models, what we've seen is that the data set that the search engines are operating on, right? The web corpus, billions of pages, hundreds of billions of sentences, actually give us a way to approximate semantics in a very powerful way, right? When I search for the phrase Usama Fayyad, I'm just making a statistical search. And yet, when I make that search, the things that pop up at the top are actually very semantically good, right? They relate to Usama Fayyad as a person and his homepage, his biography, interviews with him, et cetera. So I think the challenge for semantic search, as we think of it, more logical, more structured systems, has been to do as well as the statistical engines, and at the same time be as robust, right? The huge power of these systems is that they're incredibly robust, right? Over billions of queries, they're able to hook on to some semantic informations. And since you mentioned old papers, back in, 2001, Dan Weld and a student and myself wrote a paper on question answering using search engines. And we showed how even when you pose a full-blown question, like, I don't know, what is the capital of France, or more sophisticated questions, how do you make tasty ravioli? Whatever it is, right? The web is infinite. often the answers can be found in web pages, again, without the use of sophisticated semantic algorithms of the structured kind. So, and in fact, right, you see that now in Google today. You ask a question, it'll map that question to another question and show you answers at the top of the search page. They're often very high quality. So to be succinct here, what happens is that these statistical methods are so good at approximating semantics.
Yeah, and I mean, personally, I also believe, web search or statistical search played on another trick, which is, you may not be absolutely certain of what this person is looking for, but by giving them a choice and letting them select from the top 10 or 20 results, you're kind of letting them give you, very important hints and kind of punting a bit on the real problem. But it actually works. There's no denying that.
Sorry to interrupt. I really think that's a great point. And I would actually go even further. I would say it's giving them these hints, like you said, and it's giving them really fast. So we've gotten used to, if you don't get the answer right away, the hints kind of tell you maybe you're off in some way. And so you do another query. And Google has gotten us used to rapidly doing 3 or 4 queries. And then many of us often get the answer that we want. But you're right, that's very different than a truly intelligent system, than a cognitive model, and so on. This is just a very powerful interactive application that leverages human intelligence, right, at the core. So I do think that a lot of these applications are AI in the sense of augmented intelligence, right? Where if you put a human in the loop, as you were indicating, you get really particularly good results, which is very different, of course, than autonomous intelligence, which is this kind of much more challenging problem.
Yeah, absolutely, absolutely. So because of the dependence of AI on machine learning in most cases, particularly to build these models or help, feed stuff into the algorithms, and the dependence of ML on data, we started seeing strange exploitations, like, Uber drivers figuring out that they can fool the surge pricing through collusion. Hey, nobody make any bids at this time and wait for the surge pricing to go up and then start accepting. Or your own comments in your own work on how homeowners started exploiting the Zillow algorithms to overvalue houses or miss serious issues from an investment perspective. Where does all this take us? This kind of super dependence on data that then makes the algorithms blind to some obvious exploitations.
So I think that there are a few important observations to make here. First, as the examples you gave show, we shouldn't underestimate human intelligence, and we should beware of algorithms being brittle. That's why I don't want bombs, being guided by computer vision algorithms. What if they make a mistake, or what if they're fooled in certain ways, right? So I do think that we have to remember not to overvalue AI and to be careful, as Zillow found out to the tune of something like $500 million, right? AI can fall short, particularly in a dynamic, changing world where there are people in the loop. I think if you go to the long term, we want to endow AI with more common sense. And we have a major project at AI2 led by Professor Yijin Choi, which is the Mosaic project. And Delphi came out of that, which is an attempt to do common sense ethical reasoning. And a lot of really important work have come out of that. In the long term, we need to endow AI with more common sense so it won't make these rather dumb mistakes. So we won't be so easily fooled.
Yeah, but I guess we still don't have good answers to that yet, that robustness that we need to figure out. So while, and this brings us to a question that's really central to my professional life, at least. But while many understand the huge dependence of AI and their machine learning on data, there still seems to be a lack of appreciating the value of data and the need to have data collected systematically, standardized, managed, maintained, in useful ways to make it easy to use by AI. But why is there this lack of thinking seriously kind of upstream to make sure we collect the right data at quality and enough granularity and context to make it truly useful resource in AI?
I think that cleaning data and massaging data, right, all these metaphors we use, wrangling data, is not always glamorous. But I do think that people in the know, like you, but also like famous VC Paul Graham, like the founders of the company Trifecta, which has been very successful, and others, people who work in the trenches know that no data mining, right? You cannot make high quality bread or cake if you don't have good flour. Any chef will tell you, you need the right ingredients. And so I think that people who overlook these important activities around data do so at their peril. And they may be more of the kind of armchair theorizing variety than people who are actually active in the field.
Yeah, unfortunately, it's not translating to kind of companies, organizations taking that whole data challenge as seriously. And they need to kind of wake up to the fact that this is a key to making AI work in many cases. Oren, just thinking big, what are the big challenges that you would be interested in seeing addressed by the field of AI?
I am very fascinated with this problem of common sense, right? We've been so good at building targeted applications that I sometimes call AI savants, right? Narrow systems that play chess or Go or do object detection in a photograph, but are not general, right? They don't. We talk about AGR, artificial general intelligence. So I think that I'm fascinated by how do we build more general systems. I think that common sense is a key part of that because it can almost be defined. I like to talk about common sense as the dark matter of AI, right? That's it's pervasive, but you don't see it, and it complements what you do see, right? And physicists estimate that it's a large fraction of the universe is actually dark matter. So I think that's a great metaphor for common sense in AI. And I would go further, and I would say that developing AI systems that have ethical notions, right, that know what's wrong and what's right and can align with us on our values are also very important. We've started studying that with the Delphi project that you mentioned. We have a live demo that kind of shows you the state of the art, which, again, as you'd expect, sometimes gets it spectacularly right and sometimes is brittle and makes terrible mistakes. But that's the reality of AI. I would say Cade Metz, the author, New York Times journalist, said, "Never trust an AI demo." I would like us to remember that AI demos they can look really good for a minute, but they're brittle and they can be deceptive unless you really know how to kick the tires and make sure that the system really works.
Oren, two great quotes in one short answer. I love it. The common sense reasoning being the dark matter of AI and never trust an AI demo. You mentioned artificial general intelligence or AGI. What do you think about this? How do we need causality, knowledge, reasoning, or does machine learning make its way there, if ever, on its own?
So I think everybody agrees that we need causality and reasoning and so on. They're just intrinsic facets of intelligence. Where people disagree is how do we get there? So some people believe that inductive learning, right, of deep learning is a part of inductive learning, data-based learning is sufficient to get us there. You can even train up reasoning systems. And other people believe that we need more innate structure, more external structure. I would say that the jury is still out on these points. But if you ask me personally, I think that we cannot just rely purely on data. I think there is room and value for these other methods, but at the same time, maybe not the way they were classically done in pure logic or second order logic. We need to figure out how to put these two perspectives together. And often what we see, right, in science is the pendulum swinging, as Hegel said, right, a thesis, antithesis, synthesis. So what I predict for the next decade is synthesis of deep learning, database learning with more structured approaches.
Okay, and as we're approaching time here, I'll kind of limit us to maybe a couple of quick questions. They may not have quick answers. Is explainability of AI models important? You know, we as humans seem to be able to explain and teach others about a topic at a high level of communication, which allows transfer learning and leveraging taught knowledge in new domains. Does this map to how we do AI today?
So I have actually a pretty radical view on this point. I think that explainability is, of course, very important. I also think it's extremely hard because the systems that are built can give you explanations that are quite accurate, but incomprehensible. They just have, you know, how do you explain the behavior of a trillion parameters? At the other extreme, they can give you very crisp and simple explanations, like how Netflix explains why it recommends a movie to you. You know, we recommend this movie because you like that movie, but those explanations are not correct. They're easily understandable, but they're not true. That's not why Netflix recommended it. So I think that a more practical, pragmatic approach is actually to audit AI systems, not to rely on them being able to produce explanations, but to make sure that they're robust by auditing them. I wrote an article in Wired about this, by sending them millions of queries, which of course they can support via an API, and making sure that they're behaving in reasonable ways. I'm very worried about the emphasis on explanation, at least in the short term, the next 10 years. And I think it's much more practical to focus on auditing.
That is a great answer indeed. I've been, you know, shifting to education. I've been recently working on figuring out how to change what is done in higher ed in terms of preparing AI practitioners and data scientists in particular, who, you know, when you hire a fresh out data scientist, they typically have the instincts of, well, I'll hack a data with an algorithm and an answer will come out. And they often don't realize what it takes to make it work in the real world. One of my personal conclusions is that we need something akin to a residency program in medical school, where you kind of, when you're thrown into that teaching hospital and you suddenly see how medicine is practiced, as opposed to how it's taught, it will be a very beneficial thing for data science and AI practitioners. What are your thoughts on the missing pieces for training the right talent in data science, you know, especially since you've been a professor for a long time?
Yes, well, I think a residency program is a very valuable idea. Since time is short, let me just mention another article that I wrote just a few years back. It talked about a Hippocratic oath for AI practitioners. So it said, not only do you need them to have that practical training that you talked about, but they need to take an oath that's very much analogous to the oath that medical students take about how they use AI in ways that are appropriate and are ethical. And you know, if you search for Hippocratic oath Etzioni, you'll find my version of it. And if I had my druthers, everybody going into the field of AI, like a medical student, would formally take this oath, which reinforces the fact that we need to use AI in the right way for good, not for bad.
For the greater good, yeah. Well, Oren, I'll go to my last question here, and we are so thankful for your time. What advice do you have for companies, large enterprises, or even new startups in terms of how to think about AI? How should they think about AI from a business perspective?
I would say to particularly people on the business side is, don't let fancy talk and clever demos pull the wool over your eyes, right? The principles of business remain unchanged. And so you want to be careful to define a problem that AI can solve, make sure you have the appropriate data, and measure every step of the way how much progress you're making. I think that it's extremely important that people who are not AI practitioners are not cowed or hoodwinked by people who work in the field. And again, I don't think that people who work in the field have necessarily bad intent, but we can fall in love with the technology and sometimes make big mistakes.
Great advice. And by the way, great antidote for one of the most dangerous areas of AI, which is the overhype and kind of, dealing with it. Oren Etzioni, CEO of the AIlen Institute for Artificial Intelligence, thank you so much for sharing your wisdom, your wit, and your thoughts on these very deep and important questions. Thank you, Oren.
Thank you, Usama. It was really both a pleasure and an honor.
And with this, we come to the conclusion of our episode of this podcast of Legends of Data and AI. Tune in to our next podcast episode, and thanks again. See you in the future.
Thanks for listening to Legends of Data and AI. We hope you enjoyed our deep dive into the world of data and AI. If you're keen to learn more about making data and AI work in the real world and in any organization, join us next episode and subscribe to the podcast. As always, you can head over to open-insights.com to sign up for our email list, learn more about the work we do, and have access to data resources. See you on the next podcast.